Welcome. In this video, we will talk about I/O manipulation in C++ using the iOS and iomanip libraries. So, firstly, we have a couple of definitions. The first being the input stream, which is a sequence of characters from an input device to the computer, such as your keyboard or a microphone, etc. So it's just anything inputting into your computer. Next, we have the output stream, and the output stream is a sequence of characters from the computer to an output device. So it could be some characters that are being output to something like the terminal or another window on your screen, etc. So first, we need to recall something, and that is the syntax of cout. It has this cout and then the stream insertion operator, and then you can insert some amount of expressions and manipulators after it, each being separated with their own stream insertion operator. And we've already talked a lot about this expression thing, but what are these manipulators? Well, these manipulators are functions inserted into the output stream to format output. The first manipulators we will talk about come from the iOS library. This is a library that provides types for the IO stream hierarchy, of which iostream and iomanip are part of. So, when we include iostream or iomanip, we do not need to include iOS because these two things already include this iOS. And there are some other things that iOS includes, and you can find those here at c++.com/reference/iOS. There are a few different manipulators that we need from iOS. The first three being the ones to display floating point numbers. We have three ways we can display floating point numbers. That is in fixed notation, scientific notation, and show point notation. Fixed notation is how we normally think of floating point numbers, such as 12.2, 123.456, 1,200, and 34.567, etc., etc. Scientific notation is when we have the first part of it be between 1 and 10. So if you have, say, 12.1, you would move the decimal place over, so you have 1.21, and then that would be times 10 to the 1. So it's just scientific notation. And then show point notation means if the mantissa of a floating point number is 0, still show that 0. Don't just show me, if it's 12.0, don't just show me 12, show me 12.0. Let's look at this from a program. So we have these two variables, variable 1 being equal to 10, and variable 2 being equal to 1,234.56789. So the first example here is of show point, and we are going to show point this 0.0 of this 10.0 on this line. And you will see that this first output will say just 10 without the 0.0. And then after the show point, this output will show that 0. On line 2, or on this line, we will get output of the fixed value before. So this big number, we're going to get its fixed point notation. And then we're going to use the output manipulator fixed and then see what it looks like after. And since this is already in fixed notation, it should look exactly the same. Where we will see something different on this number is with scientific, because this is going to output the fixed point notation, transform it into scientific notation, and then output that scientific notation. So let us come over here and compile that program using G++ and the name of the program. After that compiles, we get a.out, which we can run with ./a.out, and you see here is the output. The first line, it shows the 10 before we have show point, which doesn't show us the 0.0. But once we put show point in, it will show us the trailing zeros. And then we have, as you can see, before we use fixed, it's already automatically rounding our mantissa. And then when we use fixed, it shows the entire number, including the entire mantissa. And then with scientific notation, it shows the entire mantissa still because we used fixed on this line and haven't changed it since that line. And then it changes it to scientific notation, which you can see this number, it's going to move this decimal over 3 places and then spit out this number, which would be 1.2345678, which you can see right here. And then it moved it 3 decimal places to the left, so you get a +3. And if, say, this would have some trailing zeros here, then if we come here and compile and run the program, you can see since the decimal place gets moved to the right until it is after that 1, you get a -7 over here because it needs to move 1, 2, 3, 4, 5, 6, 7 places to the right. Next, let's look at some output manipulators that come from iOS that will be used in conjunction with iomanip. Those being left and right. Left is going to justify any output that you have to the left, and right is going to justify any output you have to the right. This may not make so much sense right now, but it will here in a second when we go over iomanip. Iomanip is a library which provides parametric manipulators for I/O. These manipulators are used in line with cin. So, in order to use this iomanip library, we need to include it with the preprocessor by using the syntax include iomanip, just like this. And as always with these predefined libraries, there is a lot more things you can do with this iomanip library, and you can see those things here at c++.com/reference/iomanip, and you can also see documentation on the things we are going over in this video there. So, the first thing that we need to know from iomanip is going to be setW. And setW is going to set a width of the output. So say you want to have a space for a number that is 5 spaces wide. So if even you have a number such as 1, which would only take up 1 space, then it will output that 1 and give you some space, 5 spaces. And you would just note that you want those 5 spaces by putting a 5 where this int is being asked. And then you can come and use these 2 manipulators, left and right, to justify the content in that space. So the 1, if you set it to be used with left, it will justify that 1 to the left-hand side of the space. And if you set it to right, it will justify that 1 to the right-hand side of the space. And we'll look at this a little bit more here in a second from code. And the next thing that we want to learn about from iomanip is going to be setFill. And this setFill is going to set the blank spaces of setW. So, as in our case up here, where we had a 1 and 4 blank spaces, Well, if we didn't want to use blank spaces, we could use this set fill thing to put, say, periods. So if we look at this next slide, it may make a little more sense. Say here, we want this space right here to always be given 1, 2, 3, 4, 5, 6. So it always lines up nicely in this box, even when I put a 10 in here. Whoopsies. So how would I do that? I would use this set W right here, and then I would set a width of 1, 2, 3, 4, 5, 6 to output a buffer here for 6 characters to get output. And then you output this 10 right here, which only takes up 2 characters. And you want to justify it to the left, so you use the left output manipulator with that. So this may make not so much sense right now, but it will make a little bit more sense here in a second. Let us see what this looks like from a program. So we want to make that table here. And right now we have a pretty basic program. We just have the separator as a string. That is this separator right here that you see 3 times, and it is getting output 3 times right here. So if I come over here and compile my program, example.cpp, and run it with /a.out, you see I get the 3 separators output to the screen. But that isn't so exciting because we still need this and this. So let us see how we can do that. So let's add in some variables, the 3 headers, length, width, and area, which denote the 3 headers we have up here. We can then come here and add in this line, which builds this row right here. It outputs a bar and then a space. So we have a bar and a space always. And then we have a header, which is going to be this H1, which is length. And it outputs that length, or it concatenates that length with this string over here. So you get this and then that, and then it concatenates with this. So you get this little middle bar here, and then it concatenates this H2, which is this string width. So you get width put into there, and then it adds on this, which is that, and then the H3, which is area. So you get this, and then it adds on this end bar, which is then has a new line at the end. So the next line will output on its own line. So we can then take this nice thing that we just built and output it between our top separator and our separator for our headers and our data. So if we come over here and compile and run our program again, you see we get this nice row of headers output to the screen. But we still have not used iomanip. So let's come over here and add in these 2 variables. And then we can also add in another variable, which is going to calculate the area of those 2 variables. Since we have a length and a width, we just need to multiply the 2 numbers together to get the area. And let's see what this looks like if we do not have iomanip. So let's add in this line of code right here, which will output a row of data and then a new line at the end. There's 3 lines of data here. We're going to output this first bar, which would be this bar space right there. And then we have a length, which would be 10 that will get output. And then here's a separator, which is the separator here. And then we output the width, which would be a 5, which is here. And then we need another separator here. So we output that separator again right there. And then the area, which in this case would be 50. And then, so we get 50 output, and then we need this end right there. So we get the end there and a new line. So this last separator gets printed on its own line. So This does not have iomanip. Let us run our program over here. Let's clear this old stuff out. We can compile it and then run it. And you see we get this line that looks not so good because this is not lining up here. So how can we fix this? Well, let's only fix this line right here at first. If we put set W 6, why am I putting 6? Well, I want it to fit in this space right here. And I already have a space right here and a space right here from these two separators. So I can not put a space there and not put a space here. So I just need to cover these spaces in the middle. 1, 2, 3, 4, 5, 6. So I use a set width of 6. And if I come over here and compile that, oops, I forgot something. 1 second. What did I forget? Oh, I forgot that. So if I come over here and compile and run that program, you see it will push over, or will make a space of 6, 1, 2, 3, 4, 5, 6, and output that integer into that space there. But looky here, we want this to be justified to the left-hand side of the column, and it's currently default justified to the right-hand side. So we can come here and add in a line to justify it to the left, which would be our left manipulator. So if we come over here and then compile and run the program, you see adding that left manipulator will justify that 10 to the left. So let's add in some set W's for the width and for the area. So let's just copy this line right here and put it there and put it there. And then let's change to 5 because there is 1, 2, 3, 4, 5 characters right there. And area is 4 characters. So let's change to 4 and come over here and we can compile and run our program, and you see we get the 3 pieces of data that we want output to the screen all nicely. And you see you don't have to keep using the left manipulator every single time, because once you use it one time, it will remember it until you use the right manipulator. Let's take a look at another example of using iOS and iomanip manipulators. So we have this table of contents that we want to output to the screen. And we have all these variables to do so down here. These first row of variables is going to be the headers for up here. And then we have these variables here, which are the chapter names. And then we have the page numbers on this line here, which are the page numbers over here. So at first here, we only have these 2 lines of code, which are going to output these top 2 things here. So let's come over here and compile and run this program. And you see we get the top of the program output, or the top of this table of contents output to the screen. We get that because it's outputting this H1, which is the table of contents with the colon, which we want right there. And then we want this here. So we need to left justify this set width. And then we're using a size of 35 because this is 35 characters right here. And we're justifying it to the left there. And then we have this right justification for a set width of 5, which is the 5 over here. And why is it broken up like this? Well, so we can justify this word to the left and then this to the right so that these all line up nicely over here and that the ends on this side line up nicely over here. So, say we want to add in these lines down here. How can we do that? Well, we could add them in by adding something just like this, which is, again, going to set the justification to the left and a width of 35. But this time, instead of outputting a chapter name, we're going to output a or instead of outputting this header, we're going to output a chapter name. And then we do the write and then set width 5. And then we output the page number for that chapter. And it's going to justify it to the right so that it lines up nicely with this 10 or with this page up here. So let's see that in action. If I come over here and compile and whoops, I need to move this semicolon right here to here. And let's clear this out. And then if I compile and run this program, you see I get this output to the screen. But if you look over here, I want periods that are in the spaces that aren't taken up in this set width. So how can I do that? Well, I can add in this set fill operator, which will fill the blank spots in this set W and every set W that follows with a period instead of a space. So if I come over here and compile and run, you see I get the periods in the space instead of a bunch of spaces. And then we have 2 more lines that we want to output, so we can add in this and move this semicolon to the end and come over here. And these 2 lines have the same exact thing going on as this line right here, except for changing the chapter names for them from chapter 1 and chapter 2 and chapter 3, and then the page numbers for those 3 chapters. So if I come over here and compile and run this program, you see we get the table of contents output exactly as it is output over here. Lastly, let's look at how to set the precision of floating point numbers that are being output. And we can do that using this set precision manipulator. And we pass this set precision manipulator some integer, and that integer will set the precision of all the floating point numbers that follow that set precision. So if you say pass a 2 in here, it will set the precision to 2. So if you have 1.23456, it will cut off the end, so it is only 1.23 that gets output. But it will not edit any variables. It will only set the precision for the output to the screen. Let's look at an example of using set precision from a program. So here we have these 2 variables that are set to different floating point numbers. And down here, we are going to output those variables using set precision. And we have fixed in here because set precision will output as scientific notation sometimes if you do not do that. So just to avoid that, we have fixed being output to the stream. So the first precision that we should see, it should cut off this 5 here, and it will turn this to 12.35 since it will round when it cuts stuff off. And then over here, we will see 1,234.57 because, it will round when it cuts that off. And then down here, we have a set precision of 4, so it will output this number and then this number, both with precisions of 4. So if we come over here and compile our program and then run it, you see we get those numbers output to the screen. We get 12.35 because it is chopping off this 5 because it only has a precision of 2, and then it rounds up because 5 will cause this to round up. And then here we get 1,234.57, again, because that 6 rounds up because of that 7. And then in the set precision 4, we get 12.3450, which is 12.3450. It adds this 0 on there because we have a set precision of 4. And then we get the precision of 4 here where it rounds that 8 up to a 9 because of this 8, or because of this 9. And that is all that I have for you guys for now. Thank you for watching. and I'll see you in the next